Hello, everyone. Welcome to the show here. I'm going to be doing this every week, every Wednesday at noon Eastern Time. I'm going to be holding this Deminar, which is a combination demo and a bit about Jaxon. So give me 1 second. All right. Coming through here. Just polling the audience. Is the screen showing right now? All right, I'm going to assume that it is. So we are solving the so-called hallucination problem with Jaxon. And what does that mean exactly? Well, LLMs, they've been trained on the world's data. They look at patterns and sequences of data, a download of the web, all of Wikipedia, a bunch of books, and it looks at things forwards and backwards, and it has a good foundation of training. When you ask it a question or you prompt it, it's going to give you an answer, and it's been designed to give you an answer no matter what. If it doesn't have the facts, it will fabricate them. It will fill in the slots insofar as words being predicted to spit back out to you, to placate you and answer the question that you asked. Our chief scientists like to say LLMs are the ultimate people pleaser. They're going to answer your question. Now, can you trust that output is the big question. All right, let me get into this deck here. So let me go back up here. Jaxon is a proud IBM Silver partner. Jaxon, built with Watson X, is a powerful combination where we have access to not only secure environments at IBM and IBM Cloud, but we also have all of the LLMs at our disposal to pull in. And I'm going to show you in the demo where you can have a baseline LLM, which is the largest LLM, the most powerful, and then you can have a bunch of utility LLMs that could be more cost effective. I'll get into that in a minute. All right, so I've already covered this. LLMs hallucinating is costing a lot of companies a lot of money, to the point where a lot of the companies that we've been talking to and governments that we work with have been very cautious to implement LLMs into production workflows. I've seen that LLMs are being adopted in companies. They're getting enterprise editions where anyone in the company can make use of it, but it's typically one-off use cases where an individual will leverage an LLM for their specific data, their specific use case, but it's not in the full runtime applications. I mean, it's definitely there. There's a lot of use cases where it is, but I'm saying in so far as the curve of adoption, I think a lot of people are still concerned about this hallucination problem where they're blocking full adoption. All right, so solutions Jaxon. Jaxon has been working with the Department of Defense and in regulated industries where trust is paramount. We have to be able to use LLMs in a more deterministic way. So determinism and formal methods is something I like to describe as, think back to geometry. Think back to when you were given a problem and you had to show a formal proof to your answer. And every step of the process had to be accurate in order to get that final correct answer. And at the end, there was only one answer. Either was right or it wasn't right. Same kind of thing we're applying to natural language. In order to tee up the problems, though, the problems to be solved over here with the solvers, we need to turn it into code. We need to turn it into a program. So our secret sauce is this DSAIL technology, domain-specific AI language. So it's code. It turns natural language, which is free-form text, into code that we can create programs with, code that we can leave variables open for values extracted from LLM outputs to come in and be solved for. I'll explain more of that in a minute here, and the demo should illustrate it even further. All right, we are agnostic to LLMs, as I mentioned before. Corporation or organization data does need to make it into the mix specific to the use case. I'll get into that in a little bit as well. All right, moving on. So the process is we take the LLM output, or it could be just data to be analyzed. It could be a report that's being analyzed. It could be a background investigation, which is something I'll show in a bit here, the whole package that goes with that, all the background information that will go into the determination on whether or not someone is going to be cleared, say. Once we have that ingested, we are then going through that process that I was just talking about insofar as turning it into code that then we can reason with. Let me pause on reasoning for a second. Reasoning is what a lot of the LLM providers are saying their LLMs are doing, but they're not. They're not using logic. They're emulating reasoning. Chain of thought, which is the current latest and greatest in the so-called reasoning models, is just asking itself multiple times to pause and rethink it, but it's still very much probabilistic. And it is not something that can be trusted on the other side, because sometimes the errors can just compound themselves. I just read an article this morning where the LLMs do a post-analysis on the data that they had just produced, and they justify the reason that they produced that, and the justification is fabricated also. So definitely something to be careful of. What we're doing is bringing it into symbolic reasoning land proper. Good old-fashioned rules that are either satisfied, aka true here, or not satisfied, aka false here. So it either did or didn't satisfy the rules. And we're not just throwing one rule at the thing, we're throwing a whole bunch of rules related to the use case at hand. And that's how we're addressing the hallucination problem, by making it a very structured approach to analyzing the veracity or the truthfulness of the output. All right, I think I've covered all this. I'm going to go into this slide now. So RAG is the latest and greatest. It's what everyone's talking about. Retrieval augmented generation. Basically means you're bringing in organizational data into the mix so that the LLMs can dip into it alongside a prompt. So you ask an LLM a question, that's the prompt. Alongside that can come representative nuggets of information from these RAG techniques, which does improve the model's output. It does increase the probability that the LLM is going to spit out an accurate answer, but it is not deterministic. It is not the same kind of rigor that we're doing on the right side here with symbolic reasoning. All right, with our new platform, which is now out, and we'd love to show anyone a private demo if they're interested. Again, I'm going to keep doing these weekly, but if you'd like to talk further about it, this is what it includes. It has agentic guardrails, which are very much what I was just describing about probabilities and LLMs on LLMs. So ask an LLM multiple times in different ways just to get consensus or consistency. These show a lot of lift. These are really easy to create, and I'll show that in the demo. They don't require all the creation of the rules and the rigor that symbolic reasoning brings, but there are many use cases where a combination of agentic rails with, we've hit a nice benchmark where we're beating SOTA models by a significant amount, and it really does depend on the data and the question answer pairs that are being analyzed. This one was specific to a finance benchmark, and we'd be happy to do, and in fact we built it into the platform, do benchmarks of with and without Jaxon on your use cases. All right, policy-based verification. So we call policy rules guardrails are guardrails that are getting it to that symbolic rigor. They are converting natural language into code, and they are running it through solvers. The data being ingested is typically policy documents to configure the rules, and then these types of data inputs to verify against those rules. All right, into the demo now. So actually, I'm going to skip over to the actual thing. Give me one moment here. Exit out. Got it ready to go. All right, welcome to the Jaxon platform. So we have a number of materials online for documentation. You can get it on our website at jaxon.ai/docs. We have that benchmark interface right here to test out your use cases before and after, or with and without Jaxon. But let me get into the platform itself. So in the platform, you'll create applications, and each application will have the ability to have multiple guardrails associated with it. the heart of it is creating guardrails. So let me add a guardrail here, and we can name it whatever we name it. I'll leave it investment research. And the guardrail name can be anything specific to what we want to do. I'll just say XYZ. Now I'm going to pick, say, consistency checking here. You have choices to make when you're creating these guardrails. You can pick the LLM, you can pick the utility LLM. Again, the mainline LLM is the one that's going to be interfacing with the end user. That's what's going to get prompt in a runtime setting. The utility LLM is going to do the steps around ensuring accuracy, doing the verification. And you can get away with smaller models for that. So it's a cost-benefit analysis that you need to do to pick the model, and we can certainly help you pick the right model. We have a smattering of different choices. We're agnostic. We favor Watson X and the Granite models, but we can use OpenAI's models. We can use Amazon Bedrock, really agnostic to where you end up pulling these models from. And then you choose how many iterations, how many times you're going to ask the LLM. Do you think you're right? Are you right? Are you right? This is the iterations. And then you can choose the embedding model as well, which I won't go into details on right now, but that essentially gives some vitamins to the whole process, and you can make choices on which model to use there as well. I'm going to cancel out of this one and show you a policy rules guardrail that we've already created. So this one is, if I can find it, on a FINRA regulation, 2210D, one of my favorite FINRA regulations. Just kidding, I just learned about it. So this all came together in a matter of days here, where we found this regulation. We have a potential customer who's keenly interested in using LLMs for the compliance process, compliance inside a financial services institution to make sure it's compliant. This would be on things like emails, on internal messages that might leak out, or advertising or marketing, any type of content that needs to be analyzed for this compliance and regulatory control. All right, so this is the policy itself. This is directly from FINRA, which is based off of the Securities Act of 1933, which is a law. So this reflects the law, and everything from here is going to keep going down. So the policy is the starting point. We can add additional prompt instructions here, so it can be a little bit more fine-tuned to the use case at hand. And then we're going to click a button, and it extracts the rules. It turns this policy into a bulleted set of rules that the LLM is going to follow. This is what I've been talking about for the bulk of this presentation, is that these become the way for us to ensure that the model's output is something that can be trusted. All right, so we have a bulleted set of rules, and mind you, these are editable, so you can get in here. If you don't think it reflects the policy well, a human can get in the loop. And then we hit a button, and we turn it into code. So in this case, we are proving violations. You can also prove compliance. Proving violations in this case would be that an email, say, violated one of these rules. And you can see there's a bunch of Boolean operators here, and I won't bore you with all the code, but this represents those rules in our domain-specific AI language. All right, then we click another button, and by the way, each one of these buttons is powered by those utility LLMs that I've been describing. We hit the button, and it turns the code back into natural language and into questions that, say, an analyst would ask, questions that reflect the rules, questions that you would want to make sure that, say, an email is compliant with. So the key is going to be having these questions set and then going out and finding the answers to the questions by extracting it from, say, a new email that goes out. The question-answer pairs is essentially what we're evaluating in a runtime setting. All right, back to these questions. So these questions are editable. You can have your subject matter experts come in here and edit the actual question, add additional context. Once these questions are set, they get married together into a master prompt. So alongside the mainline question, which is, is this email compliant? You will get all of these questions married into a prompt to go out and find answers to pair it with. And then that's ultimately what's going to run through our solvers and get that yay or nay, it does or doesn't pass muster, or it is or isn't in compliance. All right, I have one more goodie if I can quickly find it here. We have created an application layer. So everything you've seen so far is something that a developer would do. They would create these guardrails. Your subject matter experts would team with your developers to ensure that these guardrails represent your policies. That's for config time, so offline before you get it to production. And then once you do get it to production, then you have this agent. So let me go back here. There we go. And now we have an agent. So this is at the interface for the end users. So say you have a compliance analyst that is now in the role of analyzing corporate emails. In this case here, we have one. I'm going to click review. And you can throw in a batch here, throw in a whole bunch of emails, and it'll flag the ones that require human review that have, in fact, tripped one of the rules. The analyst will then be able to dig into all of the violations. So if I scroll down here, you'll see that a number of them passed. Pass. Oh, I picked one where there's no violation. All right, let me clear this and go to another one and see if we can hopefully get lucky and find one of those violations, just so I can show you that you get a big red fail and then a link to go back to the policy to see where it failed. All right. Let me see if there's anything else I can fill. Oh, good. Fail. There we go. So this particular email tripped a number of rules, it looks like 4, 5. So we have a summary report on this as well, where you can just see how many rules were hit. But while I'm in here, let me just go down to this one here. I click the link and I can find in the original policy, so this is back to the FINRA regulation, which rule was tripped. So maximum sales or deferred sales charge was tripped in that particular flag right there. All right, so this is an agent that represents compliance. We are creating agents all the time now for customers that want them for their specific use cases. Again, they call on the Jaxon guardrails to ensure that it is properly being vetted and verified and have that higher degree of trust here. But this is an actual application now that you can use the guardrails alongside and accomplish a goal, whether it be investment research or regulatory compliance, portfolio management, really any use case that has some set of rules or questions that your analysts know that they ask every time of the same data is something that we can codify and bring into our process here. So love to talk to anyone that wants to get a one-on-one and go deeper into any of this. And I'm going to conclude our first Deminar. Thank you all.